Let's go over section 1.8 together. Question 1. I want to graph the inequality the absolute value of x is greater than negative 3. Now when this is a negative, you want to be extra careful. Think about it for the moment. When is the absolute value of a number going to be greater than a negative? Now the absolute value is always going to be either a positive or at the very least 0. So when is a positive number or at the very least 0 greater than a negative? Well, that's all the time. So this is all real numbers. And how do we graph that on the number line? Well, it's the entire number line. It's just an arrow going to the left and it's an arrow going to the right. It's the entire number line. Question 2, I want to solve the equation. Now, when we're talking about the absolute value, it always is the distance from 0. So we have two possibilities since this is equality. The argument, or the number inside, 2x minus 3 could be equal to 4, because if I take the absolute value of this thing, and if it's 4, you get 4 out of it. Another possibility would be if the inside 2x minus 3 was equal to negative 4. Then when you take the absolute value, it would still be equal to positive 4. So let's solve each of these equations separately. I would add 3 to both sides here. 2x equals 7. And divide both sides by 2. So my first solution is 7 over 2. Now for the second scenario, we'll add 3 to both sides. 2x equals negative 1. Divide both sides by 2. And my second solution is negative 1/2. We have two answers in this case, 7 over 2 and negative 1/2. If you're unsure, plug it into the x, and I will guarantee you that you would get 4 on the left side for 7 over 2. And if you plug in negative 1/2, I guarantee you'll get negative 4 on the left. But when you take the absolute value, you get positive 4. So they both check out, they're both good solutions. For question 3, again we have two possibilities. 6 minus 4x could equal to 5, or 6 minus 4x could be equal to negative 5. Again, I'm setting the inside equal to 5 because that will give me a 5. Or if the inside is negative 5, the absolute value would ensure it's still equal to 5. So let's subtract 6 to both sides in the first equation. We have negative 4x equals negative 1. And we can divide both sides by negative 4. As a result, x equals 1/4. Again, you can check your work, plug it into the original equation, and make sure it's equal. Similarly, on the right side, we'll subtract the 6 to both sides. We have negative 4x equals negative 11. Divide both sides by negative 4, and x equals 11/4. Again, we have two solutions for this question. In question 4, it's just the same thing, except this time we have a fraction on the inside. But I'm going to just do the same technique here. I'm going to do 5x plus 1 over x minus 1 could be equal to 3. The inside could be 3, and the absolute value would still be 3. Or the second scenario is if the inside is equal to negative 3, the absolute value of that would still give me 3. Now, how do we solve for x? For the first scenario, let's multiply both sides by x minus 1. And that will reduce the x minus 1's here. And then I will have to distribute the 3. This simplifies to 5x plus 1 equals 3x minus 3. Again, that's from distribution here. And now we could solve for x. Let's subtract the 1 to both sides. And to save time, we'll also subtract 3 to both sides, 3x to both sides. That gives us 2x equals negative 4. And we could divide both sides by 2. X equals negative 2. And of course you can plug that back into the x's and making sure this gives you a 3 on the left side. And it does, so we know we did it right. On this side, we'll multiply both sides by x minus 1. Let's multiply both sides by x minus 1. Again, this will reduce, and we'll have to distribute the negative 3 this time. And so I have 5x plus 1 equals negative 3x times negative 3x plus 3. Let's add 3x to both sides, and we'll also subtract 1 to both sides. This gives us 8x equals 2. Divide both sides by 8. And 2 over 8, that reduces to 1/4. So again, check your work, make sure that's a good solution. In question 5, I have two absolute values here, so there's actually two possibilities. One case is if the insides are exactly the same, well then they'll be equal to each other. Or there's another possibility, if one of them is just the negative version of the other, then that would also make the absolute value true. So let's suppose they're both positive, well then I could just remove the absolute values. If one is positive and the other one's the negative version of that, then it would also be true because the absolute value makes our number positive, so it would be true. So let's solve here for y. I can add the 9y to both sides. And that gives me 18y minus 4 equals 4. Let's add 4 to both sides. I have 18y equals 8. Let's divide both sides by 18 now. And y is equal to 4/9. So the first solution is 4/9. Let's look at the other side. We'll distribute the negative throughout. 9y minus 4 equals negative 4 plus 9y. And if I subtract 9y to both sides, I get that these cancel out and negative 4 equals negative 4. This is an identity, which means all real numbers is going to be our solution. All real numbers. Because that includes 4/9, we're just going to say our solution is all real numbers, because no matter what we plug in, it's always going to be true. Negative 4 is always equal to negative 4. All real numbers works for this problem. Example 6, we have the absolute value of 2x plus 9 is less than 5. This is what I call a trap. For example, if you have the absolute value of x is less than 5, I can say that x is trapped between negative 5 and 5. Now, how do I know this thing is a trap? It's because the inequality points to the left. So we can trap the absolute value of x between two numbers. Well, x is trapped between negative 5 and 5. So here, we're just going to have a more complicated equation, but we can still simplify it. We say 2x plus 9 is trapped between negative 5 and 5. Now I've translated this absolute value inequality to just an inequality without the absolute value symbol. So again, if it's pointing to the left, you just have to make it a trap. Now we have negative 2x plus 5 is trapped between negative. Let's subtract 9 to all three sides. We have negative 14 is less than 2x, and that's less than negative 4. Let's divide all three parts by 2 now. Negative 7 is less than x, and that's less than negative 2. Now if I were to draw a picture of this inequality, I would get that these are open circles, and we'll shade in the middle. And so my interval notation would be negative 7 to negative 2. Everything from negative 7 to negative 2 would be a good solution. When you plug it into the absolute value, it's going to be less than 5. For question 7, notice that this points to the right. So when it points to the right, think of it as an OR inequality. For example, if I had the absolute value of x greater than 2, you could say that x is less than negative 2 or x is greater than 2. So you'll have to be able to translate it without the absolute value. Now, the easiest way to remember this is just copy it exactly as it is without the absolute value. And then for the other scenario, you switch the direction of the sign and you make this a negative. So that's how I remember it. Let's give it a try. I can rewrite this as 4y minus 1 is greater than or equal to 2. Or I can say 4y minus 1 is less than or equal to negative 2. One version is the exact duplicate, no absolute values. The other version, we switch the sign and make it negative. So let's add 1 to both sides. 4y is greater than or equal to 3. Divide both sides by 4. Y is greater than or equal to 3/4. That's one scenario. Now for the other scenario, we'll add 1 to both sides. 4y is less than or equal to negative 1. Let's divide both sides by 4. Y is less than or equal to negative 1/4. Now we can draw our picture. We have negative 1/4 is going to be a closed circle because of this equal sign here. And we're going to shade that to the left. And we have 3/4 is going to be another closed circle, again because of the equal sign underneath the inequality. And we're going to shade to the right. Now I always draw a picture because it tells me my interval notation. This is going to be negative infinity to negative 1/4 with a square bracket. We union that together, and then a square bracket 3/4 to infinity. For question 8, it's pointing to the left again, so that tells me this is a trap. So we'll write this as 1/2 minus x is trapped between negative 5 and positive 5. Now to solve this, I need to isolate that x in the middle. Thus subtract 1/2 to both sides. Now, what's negative 5 minus 1/2? Well, that's 5 and 1/2. Negative 5 and 1/2. We have a negative x in the middle, and that's less than. What's 5 minus 1/2? Well, I know that's 4 and 1/2. Now, we have a negative here, so let's divide everything by negative 1 to get rid of that negative in front of the x. Now this is special. What happens to the inequality? It switches directions. So we have 5 and 1/2. It's positive now because of the negative. Switch the direction of the sign. This is x. Switch the direction of the sign. And this is now negative 4 and 1/2. Now this doesn't look right to me. Why doesn't it look right? Well, the number on the right is negative. The number on the left is positive. Typically, it's written the other way. So I'm going to rotate this around, but making sure the inequalities point to the same numbers. This is equivalent to negative 4 and 1/2 is less than x is less than 5/2. So basically I rotated this inequality around, but it's still equivalent. Now you could always convert this, so I can say this is equivalent to negative 9/2 is less than x, and that's less than 11/2. Now we can graph this on our number line. Open circle for both of these. And since this is a trap, I always remember shade between because x is between. And so our interval notation is negative 9/2 all the way to 11/2. For question 9, we have to isolate the absolute value. So let's add the 8 to both sides first. I have the absolute value of 4x plus 3 is equal to 6. Now, since I isolated the absolute value, and this is an equality, I know that the insides, 4x plus 3, could be 6, or 4x plus 3 could be equal to negative 6. So there's two possibilities. Let's subtract the 3 to both sides on the left side. We have 4x equals 3. And since I divided both sides by 4, I get x equals 3/4 for one solution. On this side, we'll subtract 3 to both sides. 4x equals negative 9. And of course, we can divide both sides by 4. X equals negative 9/4 in this case. Since we have two solutions, we know that this is a good answer. In this case, we have two solutions, 3/4 and negative 9/4. We do not have an interval here because there's only two solutions. In the previous question, we have a range of values from negative 9/2 all the way to 11/2. So this is an interval solution. Here we have just 2 points. When we have 2 points, typically we write our solution in curly brackets, negative 9/4, comma 3/4. But if we have a parentheses or a square bracket, we know it's a range of values between those numbers. Here we just have two answers, negative 9/4 and 3/4. Question 10, let's isolate the absolute value first before we make a decision. Add 14 to both sides. I have the absolute value of 5x plus 3 is less than 13. Now, since this space is left, it's got to be a trap. So let's trap 5x plus 3 between two numbers. That's going to be 13 here and negative 13 here. Let's subtract 3 to all three sides. I have negative 16 is less than 5x, and that's less than 10. Let's divide everything by 5 now, all three parts by 5. Negative 16 over 5 is less than x is less than 2. If I graph this on the number line, I can clearly see my interval notation. And that's going to be shaded between because this is a trap and they're open circles because there's no equal sign underneath. What's my interval notation? It's negative 16 over 5, comma 2. For question 11, again, let's isolate the absolute value. Let's add 4 to both sides. 6x plus 1/2 is less than 10. Again, it faces left, so this is a trap again. So let's trap it between two numbers. What do you think the two numbers are? It's got to be 10 on the right. On the left, it's negative 10. Let's subtract 1/2 to all three sides. And I know on the left that's negative 10 and 1/2. And on the right it's 9 and 1/2. And now I gotta divide everything by 6. It's kind of hard to work with these mixed fractions. So let's convert negative 10 and 1/2 as 21 over 2. So this is negative 21 over 2 over 6 is less than x, and that's less than 9 and 1/2 is the same as 19 over 2 over 6. And now since we have a fraction divided by another number, we can write this as negative 21 over 2 times the reciprocal 1 over 6. So again, when we divide a fraction by another fraction, a over b divided by c over d, don't forget you're leaving the first term the same and you're multiplying by the reciprocal of the second term. That's what I'm doing here. This is a 6 over 1, and that's a 6 over 1. So this becomes 19 over 2 times 1 over 6. And this simplifies to a 7. If I divide that by 3, divide that by 3, that's a 2. So I have negative 7 fourths is less than x is less than. This does not reduce. It becomes 19 over 12. Wow, look at those fractions. We all love fractions now. And we know it's a trap, so we'll shade between. What's our answer in interval notation? Negative 7 fourths, comma, 19 halves. Or, my mistake, it's 19 twelfths. I lost that 1 there. So let's correct that. It's negative 7 fourths, comma, 19 twelfths. For question 12, let's subtract the 7 to both sides. And we have the absolute value of 5x plus 4 is less than negative 6. Now some of you might think, oh, it's a trap. It faces left. But no, don't think that, because this is a negative. So be cautious when it's a negative. When does the absolute value of a number become less than a negative? When is the absolute value of the number less than a negative? When is a positive number less than a negative? Never. This is no solution, because the absolute value is always positive, or at the very least 0, and that cannot be less than negative. So this one is a no solution case for 12. Be cautious when there's a negative on the right side. Example 13, we have 4x minus 16 equals to 0. The absolute value of 4x minus 16 equals 0. So there's two possibilities. The inside could be equal to 0, or the inside could be equal to negative 0, but that's the same thing as 0. So I'm just going to use one scenario here. We'll just use the fact that 4x minus 16 is equal to 0. And to do that, we'll add 16 to both sides. 4x is equal to 16. Divide both sides by 4, and I get 4 as our solution. Now if you solve the other side, you would still get 4 as a solution. So there's just one answer, that's x equals 4. Question 14. Now we have an absolute value equal to 0, so there's essentially two possibilities. 2x squared minus 13x minus 7 could be equal to 0, or 2x squared minus 13x minus 7 could be equal to negative 0. Wait, that's the same thing as the previous case. So we'll just focus our attention on this. And we know how to solve this. This is just the factoring technique. So let's put negative 14 on the top. 2 times negative 7 is negative 14. And we're looking to add up to negative 13. So the two numbers are 14 and 1, but this has to be a negative 14. Now for this question, don't forget we're using the AC method, so let's split the middle. We're going to get 2x squared minus 14x plus 1x minus 7 equals 0. Again, 14 and 1 comes from these numbers that we found. Notice I can factor the first two terms. 2x, take that out to the front, I get x minus 7. And for the second one, I'll just take out a positive 1, because we want to leave x minus 7 left over. This can now be factored to the front. I have x minus 7 times 2x plus 1 equals 0. And so we can set each of these factors equal to 0. We have x minus 7 equals 0, or 2x plus 1 equals 0. And we all know that the first one is x equals 7. And for the second one, we can say x is equal to negative 1/2. And so we have two solutions, x equals 7 and x equals negative 1/2.